Exam questions. This question 10, column design. During the preliminary design, you have to choose between 3 different options with the same concrete quality and reinforcement quantity. Which column configuration, rectangle, squares, or circle, has the greatest load capacity? And arrange the columns with the smallest load capacity first. Prove your answer. So we have 3 cases, and we will study all the 3 cases separately. We start with the rectangle column. The column is fixed at the bottom and horizontally supported. At the top, it's 10 meters high, and the section is 1.43 by 0.7 meters. The cross section is equal to 1 square meter. The moment of inertia, the smallest moment of inertia, is then the 1.43 times 0.7 to the power 3 divided by 12, and you got this number. The radius of gyration is, of course, the square root out of the moment of inertia divided by the cross section and gives you 0.20 meter. The effective length for a configuration like that, it's 0.7 times the span, so it's 7 meters. And the slenderness is, of course, the effective length divided by the radius of gyration, and we got 34 or 35 as slenderness. We go now to the solution with the circle. The column is 9 meters high and simply supported on both ends. The diameter is 1.13 meters. The cross section is, of course, d squared over 4, which is 1 square meter. Moment of inertia, it's pd to the power 4 divided by 64, and it's 0.08 meters to the power 4. The radius of gyration is, of course, the square root of the moment of inertia divided by the cross section and gives me 0.28 meters. The effective length is then, because it's simply supported on both sides, it's 9 meters. And the slenderness is the effective length divided by the radius of gyration. It's 32. And the third example is the column fixed at the bottom, but free on top, and it's a length of 4.75 meters. It's the square cross section with side 1 meter. Of course, the cross section is 1 square meter. The moment of inertia is 0.0833 meters to the power 4. The radius of gyration is the square root out of the moment of inertia divided by the cross section. It's 0.29 meters. And the effective length is for this type of column, it's 2 times the length, 4.75. So it's 9.5 meters. And the slenderness is effective length divided by the radius of gyration and become 33. Now we'll look at it as a summary. You have 3 different cases. Note that the surface of each column is 1 square meter. And when they have the same reinforcement, so they are all equal to choose out, but the only difference is the slenderness. So the bearing capacity is a function of the slenderness. And we see in the 3 cases, the slenderness is close to each, but the smallest slenderness will have the largest bearing capacity. So the best design for strength is the smaller slenderness because the cross sections is the same in the 3 cases. So if you order them with the smallest load capacity first, then you will have first the rectangle, then the square, and the the column with the most resisting capacity is the circle. So that's why you see in buildings often a circle instead of a square or a rectangle.